Video is being created because yesterday's Math 102 video was, compromised when I was trying to download it after the 102 class. My system shut down, and in that classroom, if your system shuts down, you lose everything that was previously saved. So I'm going to take a minute and go over a couple of things we went over. Four-term polynomials. I'm going to try to do this here. Four-term polynomials, factoring, is something you don't run into a lot, but when you do, you need to know how to do it, of course. There's two types of four-term polynomials. We use grouping when doing four-term polynomials. So there is a 2 by 2 group. Of course, you're not going to see that in any book. That's a Hubertism, 2 by 2. And then there's I'm going to go down here and say there's a 3 by 1. Now, how do you know which one to use? Well, whenever you use the 3 by 1 group is usually going to be, or you're usually going to use it when there are a lot of perfect squares. So if you have a lot of perfect squares, then chances are you're going to use the 3 by 1. If you don't have a lot of perfect squares, then you're going to use a 2 by 2. I'll give you an example of a 3 by 1 first. That would be x squared plus 6x plus 9 minus y squared. Now, when you look at this problem, and I'll blow it up a little bit so y'all can see it. Where's my handy dandy remote? I just had it. There it is. It's easier for me to use the remote because it's got wires and stuff all back there. There's the 3 by 1. And notice, I'll take the red, handy dandy red Sharpie. Probably won't work. There's a perfect square. There's a perfect square. And there's a perfect square. So you've got 3 perfect squares, and 3 perfect squares usually gives you an indicator that you can group with 3 by 1. And that means group the first 3 and the last one. So I'm going to group these 3 guys and this guy. And when I do that, I get x plus 3 quantity squared using shortcut number 1 minus y squared. I just brought this down, and this using shortcut number 1, and I have a video on shortcut, the shortcuts, and we did it in class, but I need to upload it because I haven't had a chance to do that. X plus 3, that's a perfect square. This is a perfect square. This is the difference of 2 squares, which is shortcut number 3. And that will give us x plus 3. I'm going to put this in dotted parentheses, meaning that is a plus b and a minus b. And that's your final answer for this problem right here. And as you can tell, you've got a plus b times a minus b. And if you don't know your shortcuts, like I say, I'm going to upload a video, and hopefully it'll bring back some of your, or knock some of the cobwebs loose on your shortcuts. Now, 2 by 2 is not going to have a lot of perfect squares in it. I'll give you an example. Let's say I give you 2x squared plus 2x and I'm having to think this out as I do it. Plus I'll just say, well, 2x squared plus 2x plus x plus 1. Now, of course, you can see that these two can combine. Some of the time they can't. I need to really find another example. This is not a good one. But anyway, the principle or the steps is still the same. Here you have 2 by 2, so you group the first. There's not a lot of perfect squares. Find a perfect square. There is none. This is not a perfect square. Well, x squared is a perfect square. No, but 2 is not. The whole term has to be a perfect square. And this is not a perfect square. This is not a perfect square. This is not a perfect square. And this is not a perfect square. Well, 1 is, but it doesn't do you any good because it's only 1. So this one has 3. This one has 1. So this one 2 by 2. Group the first 2 terms and the last 2 terms. And this comes out and factor out a common term of 2x. And that will give you x plus 1 plus, and there's a imaginary 1 right here because there's nothing in front of this, and it can't be 0 because it cancels the whole thing out. So here is your result from grouping the first 2 and the last 2. Now, as we did in class the other day, let's take a commercial break and go back to pre-algebra. And we have 2x plus 3x. Now, the way that you do this, you combine like terms. These are like terms because these two are labels, like 2 boxes of cereal plus 3 boxes of cereal equals 5 boxes of cereal. The boxes of cereal doesn't change. 2 cans of OIL plus 3 cans of OIL is equal to 5 cans of OIL. The cans of OIL does not change. So this is the way you technically do this problem. You take the 2 coefficients and you add them together, and then you just bring the x down because it's in common. It's a label. So your answer is 6x. Now, in this case, we are able to take the 2 coefficients and add them together because they're both numbers. So we get a nice simplified term. But in this case, our 2 coefficients, and I'll do them in green, are this guy and this guy. And what's in common? Well, in common is the x plus 1. This whole thing right here is in common. And this should always match this. Now, we talked about it in class yesterday. What happens if they don't match? Well, if they don't match, then either you have done something wrong, or it is prime, or it can't be factored. And I've told the class, as well as I tell all my algebras, I usually do not put prime terms on my homework or my test. So if you get something that doesn't match, either I have put a problem on there mistakenly or don't know about it, or you have done something wrong. And chances are, more than likely, you've done something wrong, especially if they look very similar, like factoring out a negative. That's usually the case. People don't factor out a negative, and that's why they don't get it to match. So our final answer is 2x plus 1, and that's a combination of our 2 coefficients, the green, times x plus 1. And that's your final answer. And of course, that x plus 1 is a combination of, this is not a combination, it's a label. Now, the difference between this problem and this problem is here we were able to combine the coefficients because they were numerical. And here we have an x to the first term and an x to the 0 term. And these cannot be added together. x to the first cannot be added to x to the 0. Now you can multiply them and add the exponents, but you cannot combine them. So that's your final answer. Now, with this, I'm going to go ahead and take a few minutes and talk about the shortcuts. But I think I'll do another, instead of uploading the video I have, I'm going to do another video. So let me just go ahead and stop this video, and I will pull up another video in just a second.